Alright, today we're going to have some fun with SpriteKit and build a little mini simple game. So there are two approaches to getting a SpriteKit game up and off the ground. And that is and what I'll do is I'll show you, but I won't create a new project for you because I already have my project open. If you go project and you go iOS, you can go game or you can go app and then add your SpriteKit stuff manually. Now, in the past, with UIKit, I would have advocated for going for game. But the problem is that presently, Apple has not updated their game template for SwiftUI. So you would be getting a UIKit-based game with view controller, storyboard, and all that sort of stuff. And what I want to do is I want to show you a pure SwiftUI implementation here. So I would choose app and just build a regular project-based app template. So for this, choose app, go ahead through your motions, create a simple project, give it whatever name you want. I'm going to hit cancel because I already have a project open right here. Just your basic project. And I'm going to, right now before I forget, I'm going to switch to iPhone 12 Pro. No preference, I could do 13, but just feel like doing the 12. Just because I feel like. And I've added 3 images. I've added a background image, right, for my game. And I've added 2 characters. I've got Monkey there, I've got Donkey there for my game, Monkey Kissing Donkey 2. So I've got a couple of images. I'm just going to have them fly around. And I'll have Donkey fly across the screen and try to attack Monkey. Monkey will be sort of the hero in our game. And try and collide into Donkey first before Donkey collides into Monkey. And try and score points accordingly. So what we're going to do first is talk a bit about games. And games are broken down into game scenes. So without getting into too much detail about games, you'll typically have a scene for your homepage, a scene for your level 1, a scene for level 2, a scene for level 3, a scene for like an interlude scene between scenes, and so on. We're just going to have one simple scene, jump right into the game just to get you up and running. After that, it's up to you to design a game with the different scenes you want, and then you can navigate between different scenes. So first thing we have to do is we have to add a new game object here, or a new file. So I'm going to say new file, and I'm going to do Cocoa Touch class. All right, and hit next. It'll be a subclass of NSObject. I'm going to call it GameScene, and for lack of a better name, language is Swift, and give it a home. All right, so we'll come back to GameScene after. I'm going to drag it to be right next to ContentView. The thing with ContentView is what we're going to do is we're going to have it launch GameScene. Now, to do that, it needs to understand that we need some gaming frameworks involved here. And so there's 2 gaming frameworks. There's SpriteKit and there's SceneKit. So SpriteKit is for 2D gaming. SceneKit is for 3D gaming. So first thing we're going to do is go to our project settings. We're going to scroll down to the bottom. Under frameworks, libraries, and embedded content, hit the plus sign. Search for Sprite. There's SpriteKit. We'll bring in SpriteKit. Hit add. So now we have SpriteKit incorporated into our game. Now, what we're going to do is we're going to jump back to GameScene for a moment, just because I want to be able to make a quick modification to GameScene.swift, just so that it's ready to go. So first off, I'm going to replace this import UIKit with import SpriteKit. And if you want, you could import GameplayKit. Now, GameplayKit is a nice little feature of iOS that allows you to do streaming, like Twitch, for example, right, through the Apple servers. So I'll leave that to you if you ever wanted to bring that in later, but we'll leave that for now. And what we're going to do is we're going to say class GameScene extends SKScene, and we're going to talk about physics later, so I'm actually going to bring this in right now, SKPhysicsContactDelegate. So we'll bring in the interface for SKPhysicsContactDelegate. We're going to do some physics later on down the road. We might as well get it out of the way now. All right, I'm just going to hit Command S to save. I'm going to leave that file alone. We'll come back to it. We'll be doing all of our work's going to be done in here. Okay, we're just going to do one last thing first, and that is to switch over to ContentView.Swift and tell it to launch our GameScene. So what we're going to do inside, well, actually just before body, is declare a variable for our GameScene. So I'm just going to hit body, add some lines there. I will say var scene extends SKScene. Now, it's complaining. It doesn't know what scene. It doesn't know what SKScene is because we have to import SpriteKit. So let's make that happy, and we'll come back to the error at the bottom. In fact, I may not even care for it in a moment, but I may just delete it completely. The previews, that is. But let's open this up, some curlies, and let's finish defining stuff here. So we'll say let scene equal, and so our game scene that we want to jump into is called GameScene.Swift. So we'll just instantiate GameScene. Let's set some attributes for it. So we'll say scene.size is equal to CG size. So CG core graphics, that's the game object for size. We'll specify width and height. I'm going to set an arbitrary number for width at 1000 pixels. Height is 750, but of course it resizes it accordingly. We'll say scene.scale mode is equal to .aspect fill. Scene.anchor point. So what happens with what anchor point is it tells you where the origin will be. By default, the origin is in the dead center of the scene. I want to actually move the origin to the bottom left corner. I want 0, 0 to be bottom left corner, so all of my XY locations or XY values are all positive. So I'm going to say anchor point is equal to CG point, instantiated, passing some ints there of 0, 0. All right. So that is going to move the XY down there. Finally, return scene. Let's see if that makes, there we go. That looks like it makes it satisfy everything. Now, inside body, we'll dump our text hello world, and instead, we're going to go ahead and launch our game scene. And the nice thing is, all we have to do is say sprite view, and scene will be scene that we just instantiated above. We'll give it some sizing, so dot frame width. We'll just match the width and height to be 1750. Alignment, we don't really care for alignment. We want it to be like dead center. And finally, dot ignore safe area. All right, and that's it. That's it for ContentView. The rest of the work now happens inside GameScene. The purpose now is to build out our GameScene. All right, so switching over to GameScene.Swift, we're going to start by defining a couple of variables to represent our game objects. So game scenes consists of game objects, whether they be your character, they be some house, like a turret, background, right? And we define them here as actually nodes. So our game objects will be defined, use SKSprite actually to represent them. So first off, we're going to define a background image. So we'll say var background is equal to SKSprite, and we'll specify image named. So the image we're going to use, in my case, it's called city.jpg. All right, and I'm going to have another one, var sport node is equal to SKSprite. want a question mark, so get it out of the way. So I've got these variables. I'm going to add more along the way, but for now, these two are good enough. Now, maybe it wants, oops, it was actually supposed to be a extension, not a equal sign. So let me fix that. Now, in GameScenes, there is a method that auto executes every time you load the game scene. If you're familiar with UIKit, every view controller has a method that auto executes. It's called viewDidLoad, right? So every time you load a screen, it automatically executes it. In SwiftUI, we have onAppear that gets added to the body to be able to automatically execute code there. And so now what we're going to do is we're going to bring in that special method for game scenes. It's called didMove. So if I type in didMove, hit enter, auto completes. What we're going to do first is we're going to define our background. All right, we're going to define our background and place it. So I'm going to say background.position is equal to CGPoint. And we're going to put it, it's going to orient basically around the center. So we'll say frame.size.width over 2 and frame.size.height over 2. And then background. So what I'm about to do is fade it out. So background.alpha, I'm going to set to 0.3. Why am I doing this? Because we just want it to be a background texture, right? We just want it to give the impression that something's going on there, but we don't want it to be the dominant image, right? Making it difficult for you to see your other game characters, right? So the background should not dominate the screen. And so that's why we're fading it out. Sometimes less is more as a nice texture. And this is a technique you can apply even to regular apps as well. All right, now let's add this to the screen. So we're going to say add child for background. All right, and that's it. That's really all you need to be able to add something to the screen. So now we're going to run this. All right, so I paused recording just to speed up the process, and yeah, so I just hit run now, and it's there. So this is our background. It's faded out a bit. It's not exactly centered. We could play around with the centering and whatnot if I wanted to, but this is good enough for what I want to accomplish. So now you should see your background image basically and fade it out, right? And so you can play with it. You could fade it in a bit, play with the alpha, see what really suits you. So now that we've got the background there, now let's add our hero to the scene. So what we're going to do is I'm going to add a little bit more here. I'm going to say sport node equals SK, whoops. So I'll try again there. Sport node equals SK sprite node, image named, and then I'm using monkey.png. Now you'll notice I'm using PNGs for my two characters and JPEG for my background, right? There's a reason for it. It's on purpose. And that's because PNGs and GIFs, for that matter, support transparent background, whereas JPEGs do not, but JPEGs have better file compression. So you have smaller file size. So this is perfect because you want your sprites, you want your characters to have a clear background so they overlap nicely and they don't look like boxes, right? Otherwise you'd have like a white, you'd be surrounded by like a white box or a white background for every sprite image you use. And we don't want that. So rule of thumb, use PNGs or GIFs for your characters, your game objects, and use JPEGs for your background images. All right, so I'm using a PNG here. Now I'm just going to place it to the just near the bottom left corner, near the origin. So I'm going to say sport node dot position is equal to CG point 4, and we'll just say 10, 10. And then we'll say add child for sport mode. And let's run this again, see where we're at. You know what? I'm going to take away, I'm just going to switch to settings, just drop the whole portrait thing. I only want landscape left and right for my implementation. So if you want to do that as well, because I'm only going to do a landscape game today. Oh, it wants me to, let's make it happy. There we go, exclamation mark. Try again. And you know what? Let's move it further up. So it's kind of cut off there. I was gonna say 100, 100. So it's not there right now. It's actually cut off a bit. There we go. Monkey's just in the bottom corner there. He's kind of big, but that's okay. We'll work with that. And he's still cut off, which kind of tells you that my anchor point. So it's basing it on the center of monkey, and 1010 is still pushes it way far away. So I just did 100, 100. It's still now in the bottom corner, but now we have it right where we want it. Okay, so now let's start adding some bad guys. All right, we'll add some donkeys to it. So what I want to do is I first want to introduce a couple of methods, because I want donkey to be randomly placed at different heights along the screen on the right hand side of the screen, and have him fly across the screen from right to left. So so gaming is a lot about randomization. So we're going to choose a couple of methods that help with random. So I'm going to say func random. Nothing passed in. It's going to return a CG float. And we'll just say return CG float of casting float. This is kind of tricky. Casting float of arc4 random. So arc4 random is the built-in iOS method call for generating a random number between 0 and 1. Now to get it friendly to our space here, I'm just going to close up a round bracket. Actually, I just move it over. I got my round bracket there. So be very careful with the placement of your round brackets, because this will not work if you don't get this right. So you want to pause and take a moment. Let me finish this line of code. Divide by 0x, f, 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 and f, 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 f. All right? So you're going to get a warning. Don't worry about the warning. It actually does the job here in our application. But check your placement of closing round brackets to make sure that everything is in place. All right. Now what we're going to do is we're going to take this method and we're going to scale. We're going to create a new method that'll allow it to scale between a minimum and maximum value of our choosing. So I'm going to create a second method called func random. This time I'm going to pass in a min. It'll be of type CG float and have a max of type CG float. It's going to return a CG float. All right, and it'll return random times max minus min plus min. All right, so what this line of code does is it calls random and it scales it between your minimum and maximum value to get any random number between your min and max that you require. So now let's add a method that will add a bad guy to the screen. So I'm going to add a new method now. So we'll say func add baddie. All right, we'll say let baddie equal SKSpriteNode, and we'll say image named, this time donkey.png. Now, the thing is, and I'll come back to the code in a moment, I just want to point something else. If I look at monkey, right, this is monkey, right? Look at, he's facing your right. He's facing to the right. if I click on donkey, notice that donkey is also facing to the right. But if I want to have donkey attacking monkey, it wouldn't make sense to have them both facing right. Donkey should be facing left. But then the question is, do I create a second image to have him face left? Not needed, because I already have this image. This image is perfect. I could flip it about the x-axis and reuse the same image and have it facing left, right? So then they can be facing each other. That's the beauty of graphics, is that we can take advantage of the code to flip it and reuse images rather than adding hundreds of extra images that are unnecessary. So I'm going to jump back to GameScene. I'm going to flip it. So I'm going to say baddie.xscale is equal to baddie.xscale times -1. Now, let's set the y and the x for where baddie will be. So the x position and the y position. But it's actually the y that's going to be changing randomly. That's the idea behind it. I want to have the bad guy at different heights along the screen and then fly across the screen. All right? So I'm going to say let actual y equal random, passing my min and max. So my min will be baddie.size.height over 2, right? Or basically 0 plus baddie's half height. And my max will be size.height minus baddie.size.height over 2. Okay? All right. So now we have here our this will generate a random height between the bottom of the screen and the top of the screen. All right. Now baddie.position will be equal to CG point of x will be size.width plus baddie.size.width over 2. Height will be actual y. All right? So now we're going to place it at the extreme right of the screen with it encroaching in a little bit. And now let's add to the screen. So we're going to say add child for baddie. All right? Now, when he gets placed onto the screen, what I want him to do is I want him to fly across the screen. So we need to add some animations to this. We're going to add 2 animations. One is to fly across the screen, and 2 is to remove him off the screen when we're done flying across the screen. So there's actually 2 animations. And what I want to do is I want to have it fly across the screen at different speeds. So I'm going to take advantage of my random function again and randomize the duration it will take to fly from right to left. So I'm going to say let actual duration equal random. Min will be CG float of 2.0 seconds. Max will be CG float of 4.0 seconds. So between 2 and 4 seconds, we're going to get a random time. And so different donkeys will fly across the screen at different times. Now, let's generate a move action. So we'll say let action move equal SKAction.move. And you know what? I will actually just type it in just so I get the correct overload. We'll say, actually, there it is, 2. So 2, and we're going to move it to CG point, which is x will be negative baddie.size.width over 2. So basically come to the right of the screen, or basically 0 in a nutshell, and y will be actual y. All right, and duration will be actual duration. All right, now let's fix any errors we have in this line. it wants me to subcast it as a time interval object, which is fine. We'll use time interval. That's perfectly fine. So that's the first action we're going to have. The second action we're going to have is to remove it off the screen. So we'll say let action move done equal SKAction.remove from parent. So this will take it away. So we don't have a pile of donkeys at the left-hand side of the screen just piling up. I mean, that could be fun too. That could be kind of silly to have as well, but we'll leave it like that for illustrative purposes. We're going to take it off the screen. All right, so we got two actions here. We need to run them. So in order to run an action, we just say, and we want to run it off of, based on bad guys, so baddie. So we'll say baddie.run. So each of these game objects have a run method, right? And you can apply actions to them. So I'm going to apply these actions to baddie. So I'm going to say baddie.run skaction.sequence. Sequence means do it in order, right? And it requires an array. So sequence, I'll just create my own overload here instead of using one of these. And open up an array. We'll say action move, comma, action move done. All right. So now this is it for add baddie for now. We're going to come back to add baddie in a little bit to add some more functionality, but for now, this is good enough for add baddie. Now we need to run it. And I want add baddie to run over and over and over again. All right. But what I want to do, and the reason I wanted to do it is because I wanted to keep throwing donkeys at monkey. All right. So what we're going to do is keep running it over and over and over again. But I want to give it a bit of a delay between each run. So I'll give it a half-second delay, just so it looks like at least there's some, so it's easier for the user to digest it. That's why I'm doing this little delay here. So now to run add baddie over and over and over again, I'm going to move back to did move. All right, so inside did move, we added our hero, Sport node. Now we're going to add our bad guy by using the run call. So I'm going to say run. What am I going to run? Let's open up a round bracket. I'll say SKAction dot, and I'm going to repeat this over and over again. So repeat forever. All right, and inside of it, we're passing in SKAction dot sequence again. All right, and inside of it, we're going to add a array. So open up our square bracket and go SKAction.run for add baddie, comma, SKAction.wait for 0.5. All right, and that should be enough to run. All right, and so I hit pause on recording to save us some time. Then I hit record again once we had everything up and running, and you can see, let the donkeys fly. Look at them fly around like mad. They're just flying across the screen. It's pretty crazy. All right, so now we have some action going here. Now what we want to do is we want to be able to have our hero move around the screen. So now we're going to start into movements. So we're going to hit stop. And we're going to continue on. So what we're going to do first, we're going to create a new method to move our good guy. So I'm going to scroll down here. I'll put it at the bottom here. I'm just going to clean up some blank spaces here. All right, so after add baddie, I'm going to create a fresh method here. Say func move good guy. Move good guy will take in a variable called POS of type CG point. And we'll close our curlies there. So what we're going to do is now we're going to do some action moves or SK actions on our good guy, our sprite node, our sport node now. So we're going to say let action move equal SKAction.move to POS. So that'll be passed in to us. Duration, we'll just hard code it to 2 seconds. right? And it wants to be typecasted as a time interval. So we'll say time interval 2.0. All right. And what we'll do is we'll take it. So we'll do the same thing we did a moment ago with our actions. So we're gonna let it move to the screen, but we're not gonna remove it off the screen. What we're gonna do is add a little, maybe a silly effect. Just have monkey rotate, do a 360, right? So we'll add a let action move done equal SKAction dot rotate, just to illustrate, hey, you can rotate. So let's do a rotate by angle. We'll just say CG float of 360 degrees. So do a 360, right? Duration, we'll take 1 second to do it. So time interval of 1.0. All right. Now we'll just apply it to sport node dot run. Oops. Sport node dot run of SKAction dot sequence and another array. So we'll say action move, comma, action move done. All right. This is our move method, but how are we going to get this thing to move? Well, there are a few methods available at our disposal for touching on the screen and having something happen, like touch events, really. And we're going to pick one of them. But the three methods that we have available at our disposal are touchesBegan, touchesEnded, and touchesMoved. So if I start typing in touches, there they are. So touchesBegan, touchesMoved, touchesEnded. There's touches estimated properties updated. There's touches canceled. We only care about these three, right? So touchesBegan fires when you put your finger on the screen. touchesEnded fires when you let go of the screen. touchesMoved fires when you're dragging along the screen. Each of them passes in a set of UI touch objects, which in a nutshell have at the bare bones of it have the XY location of what you're touching. But really what they're telling you is which pixel was touched on the screen. Which pixels were touched on the screen, that is. And because, our fingers are thick, when we put our finger on the screen, we're not touching one pixel, we're probably touching a few hundred pixels at once, right? So we're going to get back a set. And a set, because we don't care about the order in which pixels were touched, we just want to know that we had pixels touched, right? So I'm going to use touchesBegan, right, as my example here, but you can choose whichever one you want. You might actually use touchesBegan and touchesEnded at the same time. If you want to have a move happen, like if you're doing it, like in my fighting game, for example, Monkey Kiss and Donkey 2, I would actually use touchesBegan to change my sprite to like an attack, like punch or kick, and then I would use touchesEnded to undo that change by switching back to my idle pose, right? So you can change poses as we're going, but in this case, I'm not doing that. But you could do something like that. All right, so in touchesBegan, I'm going to remove that word code, that little stub. We're going to say let POS, which extends CG point, equal touches.first. So basically give me any touch, give me any pixel, right? Dot location in self. So what this means is grab me a pixel with respect to our screen. Give me the XY location with respect to scene, right? Just hit fix, let it be happy. So a little casting going on there. Let's see if we can eliminate a lot of the warnings. And you know what? I do not like a lot of these. Actually, this I do. This overload will work. Oh, okay. No, it has never been used. That's why. So we're going to get this warning to go away now by saying move good guy POS. All right. Let's give it a run. Let's see monkey in action. Oh, there we go. And look at him flip around. There he is, moving around the screen. Now, in my implementation, I probably should go with smaller images, but I'm going to let it be. All right. So you can see you can actually move them around. If you use touchesMoved, you could actually drag them around the screen, right? But I'm just doing clicks, all right? So you can expand on this, play around with it, right? Have them do stuff. So now we have the character moving. So now let's add some physics. So things might get a bit tricky here now. We're going to add physics. Physics is actually key to any gaming application you do because you want your game objects to act and move in a way realistic with real world experiences. So gravity, bouncing into people, hitting a wall and falling down, or not passing through a wall for that matter, unless you're a ghost, stuff like that. And so physics really comes into play when we want to build a game. It's really important. We're going to do very basic physics of collision detection. Just seeing if monkey can crash into donkey and have him, gain some points. And that's our goal for today. So first things first, we're going to actually, we've already added PhysicsContactDelegate because it has a support method inside of it that we need to detect collisions. Before that, we're going to need to define a struct that defines all of our categories of game object in our game. So I'm going to say struct physics category. And we'll say static let none of type UI int 32. It won't autocomplete with without capitals. So sorry, not UI, uint 32. I've been saying UI for so much that I should know better. All right, set that equal to 0. Static let all, which extends uint 32 as well. Set that equal to uint 32.max. So the largest uint 32 number. Now let's say static let baddie extend uint 32. Now we're going to say 0b1, or in other words, binary 1. And we're going to say static let hero extend uint 32 equal 0b10, or binary 2. Now what we're doing here, and just to illustrate for the heck of it, if you wanted to keep going, you could say static let projectile. If you want to expand this further, it's a uint 32 equals, say, 0b11, or binary 3, if you want to do so. Now, why are you wondering why are we doing binary here? Because a couple of the method calls are going to require binary bits. So we're going to see that in a moment. So that's why we're stuck with using binary values for this. You'll see in a moment why. So first things first, now we're going to switch back to didMove. And what we're going to do is we're going to enable some physics here. So after add child for sport node, we're going to add physics to our game world. First things first, we'll say physics world. And these are already, so physics body and physics world already defined. They're I guess, environment variables that we can bring in. So physics world dot gravity is equal to, we'll just say the bottom of the screen is our base gravity. So we'll say CG vector of dx and dy 0, 0. Right? And then physics world dot contact delegate is equal to self. So this basically says there's a special method inside of here for collision detection. It's in self, it's in this class. Look for it here. All right. Now what we're going to do is we're going to specify some physics for our sport node, for our hero here. And the reason for that is we're going to basically describe what sort of physics our hero exuberates. So we're going to say sport node dot physics body is equal to SKPhysicsBody, and you could use there's different options to describe what your physics body is. All right, think of it as like an invisible force field surrounding your character. I'm going to use circle of radius. All right, we'll give like a circular force field around our hero. We'll say sport node dot size dot width over 2. All right, it's probably going to want, it's complaining. I'm just going to save some time and just do exclamation mark, because that's what it's looking for, really, or more. It actually wants a question mark next to sport node. There. All right, so that's describing the shape of our physics body. We're going to say sport node dot physics body dot is dynamic equals true, meaning it's constantly moving, so keep updating its values. We'll say sport node dot physics body dot category bitmask is equal to physics category dot hero. All right, so we're categorizing this as our hero. We'll say sport node dot physics body dot contact test bitmask is equal to physics category dot baddie. We're saying check for collisions against bad guy objects. There's another one I'm going to add in here for illustrative purposes, not necessary. We'll say sport node dot physics body dot collision bitmask is equal to physics category dot none. All right, so you're probably wondering, what's going on here? Why do I have these two? So contact test bitmask, basically just, if they just crash into each other. We're testing to see if it just crashes right into a bad guy. The next one, collision bitmask, is checking to see if it's sort of like colliding with, like grazing it. Right? Is it grazing it? We're not going to be testing for anything sort of grazing. Right? And then finally, one more for illustrative purposes, in case you wanted to, add some further collision detection or enhanced collision detection. You can say sport node dot physics body dot uses precise collision detection equals true. Now, this is good for characters that are like humanoid, like in our case here, has arms and legs. What we're saying here is, we got arms and legs here, or it could be like an 8-legged octopus, right? But basically, use some enhanced collision detection, right? Use the extra CPU cycles to make sure that we get it very accurate. So if it's between arm and leg, and it's not touching, it could be considered a miss and not touch. So we want to be sure that it is using precise collision detection here. All right, now what we're going to do is we're going to apply the same thing to our bad guy. We're going to specify some physics for our bad guy. So I'm going to switch down to add baddie. All right, we're going to do the same thing. Just after add child, I'm going to do the exact same thing. I'm going to say baddie dot physics body equals SKPhysics body of. So I showed you circle of radius. I'll show you another one, rectangle of. So we'll say that, donkey's a square, all right? But for lack of a better, idea, we'll say its rectangle is, so baddie dot size. That's the dimensions of my rectangle. We'll say baddie dot physics body dot is dynamic is equal to true. So it's constantly moving. Keep checking for its updated values. Baddie dot physics body dot category bitmask is equal to physics category dot baddie. So now it's categorized as a bad guy. Baddie dot physics body dot contact test bitmask is equal to physics category dot hero. So we're checking to see if it's crashing into heroes. And baddie dot physics body dot collision bitmask equals physics category dot none. So we're not doing any grazing. We just want full on collision, head on collisions. All right. So now our collisions our physics is defined for both our hero and our bad guy. So now what we want to do is we want to be able to do something with a collision. We want to be able to fire a method that will fire when collisions happen. There's one built in to our SpriteKit here. So I'm gonna bring that in. I'll fill it in a moment. Just clean up the extra blank lines there. I'll do it right out. We'll do it down here at the bottom. So first off, I want to have a method that fires whenever we have a collision. I'm gonna say func hero did collide with baddie. All right. Arguments passed in: hero, SKSprite node, baddie is an SKSprite node. All right. Now, all I'm going to do for now is just do a print to the console to say hit. Right? Just proof of concept. I'm going to come back and fill this in after. So, the method I was talking about that fires when a collision happens is called didBegin. So I'm going to say didBegin. There it is. Hit enter. All right, and there's my method. So now, what we're going to do is we're going to check to see who hit who. Did hero hit baddie or did baddie hit hero? All right. We're going to fire hero did collide with baddie if hero crashed into baddie. So first off, we'll say var first body is SKPhysicsBody. Var second body is SKPhysicsBody as well. Now what we'll do is we'll say if contact dot body A dot category bitmask is less than contact dot body B dot category bitmask. All right. So basically, if bad guy is body A and hero is body B, then first body is equal to contact dot body A. Second body is equal to contact dot body B. All right. Else, all right, the other way around. So first body is contact dot body B. Second body is equal to contact dot body A. All right. Okay. So now we want to fire hero did collide with baddie. So now we're really going to test our collisions here. So we'll say if first body dot category bitmask anded, just single and, with physCategory dot baddie does not equal 0, meaning that they're identical, and opening round bracket second body dot category bitmask anded with, so single and, physCategory dot hero, right? Then open up our curlies and we'll just call hero did collide with baddie, passing in first body dot node as SKSprite node and second body dot node as SKSprite node. All right, let's just double check our errors here. All right, I just need a little does not equal 0 there. There we go. That looks all clean. All right, we have enough to run now. Let's just run it. We're going to be checking our console down here for the word hit for collision detection. All right, and hit run. There's monkey running around. You see the words hit down here. Like if I keep scrolling up, here's a lot of hits going on. So I know that collision is happening. So we got collision detection going. Now, let's apply something practical to collision detection by scoring some points. All right. So now it's going to hit stop here. And what we're going to do is we're going to give some scoring to our game by adding labels to the screen. I'm going to add 2 labels to the screen. All right. One will be the title label for our game, and the second one will be the actual score. So I'm going to scroll up to the top here. And we have here 2 variables here. Just going to add 2 more. And well, more than actually 4 more. So we'll say var score is an int. All right. We'll say let score increment equal 10. So we're going to increment our score by 10 points every time. We're going to add a couple of labels. So var LBL score extends SKLabel node. Sorry, not extends, but equals SKLabel node. I'm going to instantiate it. And var LBL title equals SKLabel node. Now, in the UIKit version of this, there is a drag and drop editor for adding labels like this. It doesn't work here in the UIKit world. It's pure code for this. So you would have been able to do this if you had generated the game project, the pre-built game project. You would have been able to drag and drop labels. So what we're doing here is slightly different. What we're going to do is we're going to create a method to initialize our labels. So I'm going to do it just above didMove. I'm going to say func init labels. And we'll initialize our labels. So I'm going to start with LBL score. So I'll say LBL score dot name is equal to LBL score. Give it a label. We'll say LBL score dot text is equal to score with a colon and a space after. We'll say LBL score dot font size is equal to, we'll set the font to be like 64. We'll say LBL score, and of course you can play with this stuff afterwards. Dot font color is equal to dot red. So I just want the font to stand out. We'll say LBL score dot position is equal to CG point of, and then X and Y. We're just gonna hard go this to like 200, comma 200. All right, and of course you can play around with the XY location as well. And we'll say LBL score dot Z position is equal to 11. Now what I'm doing here is I'm actually pulling it to the front of the screen on top of any and all game objects. And we'll say add child for LBL score. All right. Now I want to do the same thing. I want to do the same thing for title. I'm just going to copy and paste. I don't feel like retyping this stuff. And you could probably do the same as well. And just change LBL score to LBL title. But be careful with copy and paste. If you get too relaxed with it, you will make mistakes. So if you feel like retyping again, that's fine. So LBL title will now be, sorry, so we'll change it to title here. And this will give a title to our game. I'm just going to keep it simple, like my game. Keep the font, keep the color, it's fine. But the location has to be changed. I'm going to put like 500, 500. All right, and that's it. So I got my labels initialized. Now I need to actually call init labels. And what I'm going to do is I'm going to call it inside didMove. So we have didMove down here. I'll make it the first line of code. So if you're still typing, you can still see it. I'll say init labels. All right. It'll be the first line inside didMove. So you can see here inside didMove, there's init labels that we just created above. So now we have our labels up and running. Now, what I want to do is I want to be able to actually set up our labels to animate and update the score constantly. First thing I'm going to do is I'm going to hard code my score, and I'm going to add in my title label by hand. So after background, I'm going to say lbl title.alpha equals 0.0. So I'm going to just do a bit of an animation. I'll do an lbl title.run for SKAction.fadeIn. Notice that there's fading methods that you can add in to fade things in and really add some flair to things. So I'm going to say with duration, it'll take 2 seconds to add it in. And for my score, what I'm going to do is, and I'll do the score at the end of didMove. So I'm going to scroll down to the end of didMove after this repeat action forever. For adding donkeys to the screen, I'm going to say score equals 0. We'll say lbl score dot text is equal to score with a slash and a round bracket score exclamation mark. And let's animate this in. So we'll say lbl score dot alpha is equal to 0. And we'll say lbl score dot run for SKAction.fadeIn. We'll just say, again, 2 seconds. Now, last thing we're going to do is we're going to apply this exact same thing to our scoring mechanism inside Hero Did Collide with Baddie. So I'm just going to scroll down to Hero Did Collide with Baddie. Where we have our print hit. I'll leave print hit, that's fine. What we're going to do is we're going to update our score. We're going to say score equals score plus score increment. We'll say lbl score dot text is equal to score with a slash round bracket score exclamation mark. We'll say lbl score dot alpha is equal to 0.0. We'll say lbl score dot run for SKAction.fadeIn. Duration 2.0. All right, and that's it. Let's give it a run, and let's see our scoring mechanism in action. There's our title. Here's our score going wild. All right, so every time I move monkey, he keeps colliding with donkey. Now, of course, my characters are huge, so you can see that the score is just taken off like crazy. I mean, I could probably scale down monkey and donkey, and have maybe a bit of more of a challenge in scoring. I could fine tune the game to maybe have monkey and donkey flying around the screen, like maybe not just straight, but like at an angle. Right, but there's more I can do with this game. But if you look at it here, we've got the basics of SpriteKit down and running. What we have here is just the ability to add. We've learned how to add sprites to our screen. We've learned how to move around the screen. We've learned how to have bad guys move across the screen. We learned about animations. We've learned about randomization. We've learned about physics. And we've learned about adding labels and keeping score. So there you have it. So now it's up to you to take this game, play with it, grow it, see what else you can do with it. And until next time, I'll see you in the next tutorial. Take care and bye for now.